Hi guys, welcome back to my channel. So in this video we are going to understand how a simple 8-bit processor fetches an instruction from memory using a single bus architecture. Okay, so let me go ahead and first explain this diagram a little bit. Okay, so what you guys see over here is basically an 8-bit bus. Okay, so this is an 8-bit bus and it is basically connected to many components, as you guys can see. So we have like MAR, memory address register, which is responsible to hold the address, MDR, which stores the which is responsible to read write. Okay, and I have like explained all these components in details in my previous video, so you can check out the playlist. Okay, and this is the ALU, which is responsible for performing arithmetic units. Okay, and we basically have some registers over here. This temporary register, this is also a temporary register. Okay, so we have like R0, R1, these are registers, and we have a program counter over here, and we have instruction register over here. Okay, so to perform the fetch execute cycle, it takes, so it's gonna take, so let me write it over here using a pen. Yeah, so it's gonna take like 3 cycles to perform the fetch execute cycle. Okay, so I will go ahead and explain each cycle step by step. So this is T0, so this is the cycle 1, and then we're gonna have T1 and T2, so the first cycle, second cycle, and the third cycle. Okay, so what's basically happening is that in this system the data, it travels 1 step per clock cycle and over the shared bus. Okay, and we're basically using like RTL to describe those data transfers. Okay, and RTL, if you guys are wondering, so RTL is basically a register transfer language to describe the data transfer over here. And I have already made a video about RTL and how it works. If you want, you can check it out in my playlist. Okay, so in the exam, I remember the professor basically like gave us this this structure that you guys see over here. Okay, and we had to write the RTL of this one. Like we had different instructions given. Like here I'm explaining the fetch execute cycle, but there are other stuff that I will explain in further videos. So like you guys can be asked to do any of them, and then you, I guess, basically have to like memorize the steps of the RTL. So like memorize it very well, because you might have to write that in the final exam. Okay, so yeah, so let's go over it. So what's gonna happen is basically the PC, the program counter, it's gonna send the value to the bus. Okay, so the program counter sends its value to two components. Okay, so first it's gonna send it to MAR and then to ALU. Okay, so the value is of the PC counter is copied into 2 places, into MAR and into ALU. Okay, into MAR, because MAR stores the address, right? So it's gonna store the address of the instructions we want to fetch from the memory. Okay, so it's gonna go ahead and store it into the MAR, and then it's gonna go ahead and store it into ALU, so it can increment the value of the PC. Okay, so I was just roughly explaining it. So now let's go over the actual steps. So the first step, let me change colors. First step that you guys see, you're going to write in the RTL is you're going to say enable PC. Okay, so this is the RTL, so I will write the RTL over here. Okay, so this is what you guys have to write in exam. Okay, so enable PC, so the PC is enabled, and what's gonna happen next, we want to send its value to the bus that we see over here, right? So sending the value of this one to the bus. So then we're going to say like the PC. So here you see the value of PC stored into the bus. Okay, so now the bus contains the value of PC, and now what do we want to do? We want to copy its content into the MAR. So because the MAR stores the address, right? So it's gonna store the address of the instruction we want to fetch from the memory. Okay, so it's gonna store the address of the PC over here. Okay, so next what do? We're going to load MAR, right? So load MAR, and then what are we doing? So whatever the content that the bus had from the PC, right? So we're going to send that content into MAR. Okay, so yeah, this is what's happening. So again, what we did, we enabled the PC, pass the PC content into the bus, and so now the bus contains the content of the PC, right? So now we can pass that into MAR. So yeah, that's basically it. And since we're copying it into two places, so what's our next step? We can, so now that we have bit copied into MAR, we can also go ahead and copy it into ALU, right? Because we want to increment the value of the PC. So then we are going to take the value that was stored at the bus into the ALU. Okay, so and because we want to perform an addition, because we want to increment the value, so we need to tell the ALU the mod that we want. So we can go ahead and say ALU mode add. Okay, so ALU mode add, and then what we're doing, we're passing the content of the bus into the ALU. So here you guys see this is the value of the bus that was stored from here is now passed to the ALU. And after performing the addition, after incrementing the value of the PC, what do? We're going to simply store it into a temporary register. Okay, so which is this one, the result register. So now what do? We're going to load the result. So yeah, the load result, and then passing the ALU content into the results. Okay, so yeah, it's passing ALU into the results. So this completes our first cycle, which was basically passing PC contents into ALU for increment and MAR so that it can hold the address. Alright guys, so let's go over the second cycle. So in the first cycle, what we did, we copied the content of the PC into the ALU and MAR, right? So in this cycle, what we're doing is, since we have already copied into MAR and it stores the address, right? And we want to read that address. Okay, so what we're going to do, we're going to read that address from here. Okay, so what I'm doing right now, I'm just like basically explaining what's happening in this cycle, and then I will explain the details later. Okay, so so the MAR, it's gonna read read from the memory the address that we passed in. Okay, and then it's gonna be stored, that address is gonna be stored into the MDR, because remember MDR, we can read from the memory and we can write to the memory, right? Because MDR is used to read and write. Okay, so then this is gonna happen, and then this result register that we used in the previous cycle, because we incremented the value of the PC and then stored it into ALU, remember? So now this result, it contains the value, the incremented PC value, right? So it has like PC plus 1. So now we can go ahead and pass this value back to the PC. Okay, so this is what we're basically doing in this cycle. So let's go ahead and explain you guys into details. So first, what's happening is we are enabling the MAR, because we stored the value into MAR, right? So and now we want to perform the read operation to it. So what we're going to do, we're going to enable MAR. Okay, and then we're going to perform the read operation to it. Okay, so memory read, and then what we're doing, we are loading the MDR, because we want to pass we just read the memory address. So now the memory address of the PC, right? So we just read it, and we can go ahead and store it into MDR. Okay, so what we're going to do, we are going to select the MDR from the memory. Okay, so we are selecting MDR, and we are placing from the memory after reading the contents, right? Because MAR we can remember read from the memory, and MDR we can read and write, perform both the operations. So after reading, what we do, we're going to pass what we read from here into MDR. Okay, so yeah, memory of the PC that we just read, we're going to pass it into MDR. Okay, and then after storing it into MDR, because in this cycle we're doing two things, right? Storing into MDR and then putting back into the PC, right, the incremented value. So now moving to our next step, which is because this contains the incremented value of the PC, so now we can go ahead and pass it into here. So for this one, we have to enable this result first of all. So we're enabling this result register, and then we can, now this one stores the value, the incremented value, so we can go ahead and pass it to the bus. Okay, so after passing it to the bus, I can change the colors. Okay, so now this bus contains the incremented value of the PC, and then we can simply go ahead and pass it to the PC. Okay, so yeah, so the result gets passed into the bus. Okay, so the result goes into the bus, and then the value of the bus is stored into the PC. The value of the bus gets stored in the PC, and this completes our second cycle. So let's go ahead into our last cycle, which is this third cycle. Alright, so let's talk about the last cycle, which is the third cycle over here, right? So basically in the last cycle we stopped at MDR, right? We stored the content into MDR, and MDR is responsible for the read and write to the memory, right? Okay, so in here what we're basically doing in the last cycle, last clock cycle, is we are transferring from MDR to IR. Okay, so because IR, because it holds the instruction currently being executed. Okay, so this is what we're basically doing over here. So how are we doing this? So okay, so from here we are passing the data from here to IR. Okay, so from this to the bus, and then from the bus to the IR. Okay, so what we do, enable MDR, right? And next the MDR contents are stored to the bus. Okay, here you see, and then from the bus we store the contents into the IR. Okay, so then now it completes our cycle, the fetch execute cycle that was supposed to be done in 3 clock cycles. Okay, so to review what we basically did from the first cycle, what we did in the first cycle, we copied the content of the PC and we passed it into IR, ALU and MAR. Remember, from PC to ALU and MAR, ALU so that it can increment the value by +1, right? So we incremented the value of the PC and then stored the contents back to the PC, right? And then here we stored the memory address into the MAR, and then we read from the memory, and then we stored the contents into MDR, and from the MDR we stored into the IR. Okay, so this is a recap of this video, and there's something that you guys have to know. So here, let me just remove my annotations. Okay, so this is important for you guys to know, that every instructions performed in this organization will always have these 3 clock cycles. Okay, so no matter what you get, so it's always gonna follow these 3 clock cycles. Why is that so? Because it is required, since the processor must fetch the instructions. Okay, like after I have explained you guys this, so let me just ask you guys a question. Like, so here, if I ask you guys to perform a register to register operation, okay, so for example, if I give you guys like register to register, operation NI, and I ask you guys to like perform this command. Okay, so you have to like move this. Okay, so I give you this command, which means like move R0, the value of R0 into R1. Okay, into the R1. This is a comma. Okay, so how are you going to write the RTL for this? If I ask you guys to write this, so we want to move the contents of R0 into R1. So how are you going to write the RTL for this? Okay, so let me know in the comments below how you would write the RTL for this one. And that was it for this video. Thanks for watching. Bye.